Hey folks, here's a quick video on, well, not so quick, but this whorled top bottle. The thing that makes this difficult is that the bottom part of the bottle, this straight section, is not perfectly round. But anyway, I saw it in a grocery store and thought to myself, man, what if I could model this in freecad? And it turned out all right. Um, so we'll start with an empty file in the part workbench. It took quite a few tries to get this right. You're going to start a new sketch on the XY plane and draw a rounded rectangle. Okay. I'm going to mark these two lines equal. Excuse me. There we go. I'm going to constrain a radius on the corner of 30 millimeters. Constrain a length of 10. Now this whole thing can float, which we don't want. We're going to take two of these inside points and the center point and constrain them symmetric. If I can get this to work here. Click off and try again. There we go. Fully constrained. Alright. We're going to use this sketch again 4 times. So I'm going to go, oops, my bad. I'm going to go into the draft workbench and make 4 clones of this sketch. There's probably other workflows for doing this, but 3 is actually enough. Now, let's see. Take our second sketch and raise it in the z-axis, about 5 millimeters for now. Take our third sketch raise it also in the z-axis. We'll just say 10, and these values are obviously subject to change, but we'll make the last one 15. The original sketch, I'm going to go into the curves workbench. If you don't have curves, you can download it. It's a free add-on, but it's a very powerful workbench for doing these types of models. Our last clone, we're going to create a join curve from. And then our join curve, we're going to discretize. Excuse me. It didn't quite work out. Click on it in the tree view, so select the whole sketch and click join curve. There, now we have a join curve that's one solid wire going all the way around. We're going to discretize that join curve a total of 32 times because there's 16 flutes going around the top of the bottle. Same goes for our second clone. We're going to click on it in tree view, create a join curve, click on that join curve and discretize. Discretize it. There we go. Also 32 occurrences. And click off. Alright. Now I'm going to click on, I'm going to go back to the part workbench for now. I'm going to click on our top sketch and click create a new sketch on the objects XY. We're going to hide all these old sketches in our join curve. Yeah, so we're just left with just a set of points. We need our external geometry tool. And I'm going to bring in all 32 of these points. Click off of that. I'm going to create a 3-point arc going from each of these points. Just floating off in space for now. Don't make them coincident to anything, as you can see. Bear with me. I'm going to have to do this again in a second. So part of the challenge of making this is that the base is not perfectly round. So anyway, we're going to select one point and one arc and dimension it. This would be easier with a spreadsheet, of course, or varsets. But each of these has 1 millimeter of offset from the parent point. If there's an easier way of doing this, let me know in the comments. I'm sure plenty of you are well versed in this sort of modeling. Oops. Alright, our sketch is fully constrained. Just going to take a look at it for a second and close it. We'll be using that sketch later on, of course. Using our, not this join curve, but this join curve. We're just going to leave that as it is for now. Right. Going back to our completed model. You can see we have a similar sketch plotted out. Alright, I'm going to create a new sketch on the XY plane. I'm going to offset it to 50 millimeters. This will be the top of the neck. I'm just going to create a 30 millimeter circle. And close it. And then I'll create another sketch and offset it to 53 on the XY plane. Create another 30 millimeter circle. This is just for tangencies. Just to create tangency in the completed neck. So you need two sketches. Now I'm going to create a primitive shape, which in this case is a helix. So the radius of it does not matter too much. I'm going to put it on the outside of the part. The height matters a lot. You have to match it to the height, total height of all your profiles. So that's 53 millimeters. Actually, it's 55 millimeters. I'm going to raise this one up above it. 2, 3, 4, 5. Good. So the height of the helix will be 55 millimeters. The pitch will be, it's a quarter turn going around, so it's 220 millimeters. The outside radius, we'll just say is, I could look at my original sketch and determine this, but I think it's around 40. It doesn't matter too much as long as it has the proper amount of turns and pitch. So there's our sweep profile. Good. Oops. I accidentally created two of them. We'll just go ahead and delete that one. We have our helix for this sweep profile. And alright. I've actually bungled this a little bit. This video is obviously for entertainment and informational purposes, so not claiming to be the foremost modeler in the freecad community, but I do like the software quite a bit better than my than the commercial program I used in the past. Alright, we're going to close that. Alright, let's set the microphone down for a second. Control selecting. Yeah, this is what we want here. to bring in the correct set of points. Perfect. All right, I got it here. So again, using our external geometry tool, we're going to bring in all these points here quickly. We're going to create another 3-point arc. I don't know why it's not highlighting there. It should be highlighted. Oh, that's a pain. There we go. You'll know if you miss the point because you'll get a near tangency. It won't be fully constrained when you're through. You'll get near tangency on the, or open wire, etc. on your point. I need to go into settings and change my pick radius. So just zoom in and make sure these are tangent. I think that's going to work. We'll find out in a minute. There we go. Didn't want to pick out that point for some reason. Alright. Now it's important that to note that the flower shape is rotated 1/32 of a turn. We used a different set of points when we did this shape than when we did the first one, and that's for a reason. Oop, missed one. The reason is, you'll see in a minute, but when you rotate the profile and sweep it, the rotation is necessary. Don't know why it worked so well the first time, and now I'm having trouble with it. Just the way it is, I guess. Alright. Now the only thing left to fix is that one. I'm going to press C to make it coincident. And we're fully constrained. Now bring back our base sketches. You can see this one is, now you can see, yeah, they've been rotated. Just taking a look at our various profiles here for a second. Now it only takes 4 profiles to make the top of the bottle here. And click on our 4th one and drop it. Drop it down if it'll let me, which it won't. You need to see if I can drop it down. There we go. I'm going to drop it down to 5. We'll hide our discretized edge. And that's just about right for now. So our sketches in order are sketch 001, sketch 004, sketch 003, and sketch 002. So 1, 4, 3, 2. We're going to go ahead and create our sweep now just to test it. In order. Oop. And we have a problem. Okay. You gotta select all these points. Shift select. Hold down Shift and select them. Make them construction geometry. Now we'll go back into our sweep and sketch 001 is there. Sketch 004 is not though, so we need to do the same thing with it. Scroll down, find all these points, select the bottom one, hold down Shift and select the top one, then click to make them construction geometry. Hit close. Alright, we're good. Again. So we're going in order: sketch 001, sketch 004, sketch 003, and sketch 002. Click on our sweep path and click the helix. Click Done. We want to create a solid, and we want FreeNet to be selected. Now that is pretty good. It's not quite what we're going for here. See if we can fix it in a minute. Go back into our sweep, click on sketch 004, click on our axis of rotation, and select the angle. We want about 5 degrees of rotation on it. We'll recompute our sweep. See if that helps. our top sketch, which is sketch 002, we're going to rotate it about 5 degrees. And that's to create tangency with this line. It's actually too much. I think about 4 degrees is what we want. That's to create this seam line smoothness. Alright, I don't know why we shouldn't have 2 sets of vertices going up like this. There we go. Had to raise it up to 7 millimeters of height. Alright, that's looking a lot better. We're going to hide our helix. That's the profile more or less that we want. I'm going to hide our sweep for now just so we have wireframe view. We're going to go back into our original sketch. See if I can lower it. Yes, I can. And drop it down about 10 millimeters. That's to create a loft. I'm going to create a loft between the sweep and an extrude. Just to make this easier, I'm going to go back into curves, or I may already have it. Just to make this easier, I'm going to go back into curves and create a join curve from that sketch. And then from that new join curve, I'm going to click on it in tree view and create a split curve profile. And we're going to split it 32 times. It's similar to discretizing it, but not quite the same, of course. That will form our extrude. So I'm going to go back into part, click extrude on our split curve, and go down 100 millimeters. Very nice. Now we'll bring that back. We'll hide that for now. Bring back our split curve, and sketch 001 is the 2 we want. I'm going to create a loft. Now in the original I used, see if I can find it, for the loft. Yeah, there were 3 profiles in the loft, 2 split curves. Yeah, 1 to create tangency. And then our original sketch. So I'm going to go, go back into, I'm going to turn off sketch 004. We're not going to use that. I'm going to take our split curve from the extrude. I'm going to go into draft and clone it. Go back into part. Take our cloned split curve and go into position and raise it in the z-axis 3 millimeters. So now we have our 3 parts of the loft. So we have split curve 001, and then our sketch 001. The three of those should work fine to create a loft with. Start with split curve 001, and then sketch 001. We're going to create a solid. We do not want a ruled surface, and it doesn't need to be closed. That looks pretty good. Let's see if we have tendency when we bring back our sweep. That looks about right also. What I would like to do is go back into the loft and see if I can rotate this profile 5 degrees, minus 5 degrees. It's going to take a second to recompute. Alright, that didn't help us. 10 degrees. Alright, it's not wanting to, sometimes you have to fiddle with these profiles to get them to do exactly what you want, but you can go into position and raise it up to 6 from 3. Your mileage may vary, but this is essentially what you get. Alright, so we're just about done. I'm going to create a fillet on the bottom of 10 millimeters. Create a new sketch on the bottom. I'm going to create a point right on the center axis and close it. There might be a better way of doing this, but create a new sketch in the front view. Going to create a polyline going out to here, back up to the center line, and down to the center axis. We're going to view our section. We'll bring that out a little bit. We need to create a fillet across the top. I'm going to delete that tangency constraint. Create continuity between these 2 points. Oh bugger. Let me try this again and delete all of this. Shift select all that and delete it. Try it one more time. Straight across the top, down at an angle, back and back. Now we'll create a fillet between these 2 edges. I can create some coincidency here. And that's right about there. I'm not going to bother to fully constrain that one. We're just going to go into Revolve, select Reference, click here, click on the center line of the sketch, create a solid. Click OK. Alright, perfect. That's exactly what we want. Click first on our fillet and then on our revolve. I'm going to perform a cut. And I'll be filleting this inside radius of, we'll see if 10 works. Works just fine. Alright. Now I'm going to create a primitive shape, a plane. We're going to say 100 by 100 millimeters so it'll be visible in the 3D view. Perfect. Close that out. Click on our plane. Click, oops. I'm going to undo that. And our plane is gone. There's some quirks in freecad, of course, that you get used to using. It's a great software. I love it, but try this again. Good. Click on Attachment Editor instead of Transform, which is what we want. We want to make sure the rotation angle is set to 90 degrees. I'm going to rotate it up. So we're perfect right here is what we want. Now we'll set the rotation angle to 360 divided by 8. Excuse me, 360 divided by 16. And flip it up 1 degree, 1 rotation increment. Now we can click on our plane, create a new sketch on the plane face. You're going to turn off the plane. There we go. And just sketching out a basic profile here using polyline. There we go. This should probably include some fillets. So I'm just going to create them quick. Notice I'm not using a B-spline because B-splines can be a pain. I'm not going to fully constrain that. And make sure you pick out a line, the line that touches the end. Excuse me, we'll start from this end because, yeah, there we go. Less interference. So you pick out the point at the end of the line, create a new sketch, normal to edge. We'll zoom in, create a circle with a diameter of 2 millimeters, close it, create a new sweep, sketch 008, sweep path, and then click on sketch 007 in the tree view. Click done, click OK. And we see we don't have, it doesn't quite touch and create that rib that we want. So we'll go back into sketch 008 and increase the diameter to 5 millimeters. It should be about what we want. So we'll click on our sweep, go into the draft workbench, click on modification, array tools, and polar array. We want 8 occurrences. Make sure you click reset point, and then there we go. Go back into the part workbench, click on our fillet and our array, control select fillet and then the array. Let's try this again. Fillet and then control select the array from the tree view, click cut. There we go. Alright, just about done. We're going to turn off these 2 sketches so they don't interfere with what we're doing. Now for the click off in the front view, I'm going to create a new sketch. We're going to view the section. Now this is not quite tricky, but we're going to bring out this point and this point right here. We're going to make 7 ribs going around the bottle itself. I'm going to snap a construction line between those 2. I'm going to create circles. Excuse me, we want real circles, not construction circles. 5 millimeters, 5 millimeters, 5 millimeters, 5 millimeters, 5 millimeters, 5 and 6 and 7. Alright, perfect. Now we're going to snap construction lines again to the center of each of the circles. And to the point. Alright, now we're going to click on shift select all of these lines, but not the first one, the long one, and click equal. Boom. Alright, that's more or less what we want here. Now we can close that. Go into sketch 009 part compound and explode compound. Now we have our exploded sketch with all these different circles. Now there's 9 components to it. See if I can turn off our, there we go. Hide our loft, sweep, and extrude for now. Part 0 on, part 1 we want, part 2 we want, part 3 we want, part 4 we want, part 5 we want, part 6 we want. We don't want that part. I'm going to delete it. And part 8, I don't see that showing up either. So there we go. There's our 7 circles. Now we're going to click on, we're going to use our split curve. May better not use a split curve. We're going to use, yeah, the join curve, the underlying join curve. That's what we want, not the split curve. We're going to use that as our sweep profile. We'll let that compute for a second. That's a wild result, guys. Not sure why it did that. I'll try that again. Delete that sweep. There we go. Try that one more time before we resort to something else. Done. I have a feeling it's not going to work. Yes, it does the same thing again. Alright, we're going to delete that sweep. Go into don't want sketch 006. We're going to use sketch 001 as the sweep path. See if that works. This worked flawlessly in the original model. I don't know why it's giving us so much trouble now. I'd imagine it's because the starting point of this join curve is. Let me try going into draft, cloning the join curve, and then rotating that join curve 90 degrees. Okay then. Now you can see that vertex is in line with these. I have a feeling that that might help us. Might not too. Yeah, it's not quite in line. Now you may be thinking your sketches would be a lot easier to deal with. Alright, let's try using sketch 2 as the sweep path. You may be thinking, perfect. That's what we want. Delete that clone join curve. And this could be probably accomplished with a linear array, as you can imagine, very easily. But I'm not. This is the way I did it in the original. Okay. Now we have all these sweeps. I'm going to close or collapse our exploded sketch for now. I'm going to shift select all the sweeps, go into part, compound, and compound them together. Going to bring back our cut. Click on the cut and control select the compound. I'm going to perform another cut. You can see that ribbing has been completed. I'm going to hide all of our sketches. See if we can fillet this. And it works. Alright, we're going to undo that fillet. Control select each of these edges in order. Should be a total of 14 of them. We'll create that fillet. We're going to say 2 millimeters, see if that works. Let that stew in its own juices. Missed one. Not the best form, but we'll just go ahead and add an extra fill into the tree view for demonstration purposes. Alright, we're almost done here. We have our fillet. We're going to add our loft, our sweep. Now we need one more thing, and that is the front view. I'm going to add the neck of the bottle. I'm going to bring in zoom in real super close. Bring in that point, or that line rather. Convert it to construction geometry so it doesn't mess with us later. I'm going to go up vertically using the polyline. Out, up, in, up again, and then over to our center axis. Down and finish. Dimension that, we'll say 5 millimeters. Bring it out 3 millimeters. up another 3. Back in 3. Up 10. And then we're going to click this point in this line and make them coincident. And for this, we'll just go ahead and dimension it off to 25 millimeters. Doesn't matter too much. Click close. I'm going to revolve that new sketch, sketch 10. Select a reference line, the center line. And we want to create a solid. Alright, we got a wire not closed error. I have to go back into that sketch. Even though it's fully constrained, sometimes you get these. There's a way to highlight those. So bear with me for a second. There we go. Yes. Now we're going to take our revolve and our fillet and union them together. Take our loft, here a sweep and our loft, union them together. And then we have our two fusions. We union them into a single solid. This video is plenty long enough, so I'm not going to be adding the threading or the bottle handle that you see in the other model. There it is. You can see we added a threaded neck and a handle to the bottle. Won't be doing that here, but let's see if it takes a thickness.